Senior Developer Advocate. I'm here with Eduardo from SUSE. So we're going to be talking about running K3s on Equinix-Metal, and we have a special guest here. So I'll pass this off to Chris Privitere here at Equinix, and here, Chris, take it.
Hi, I'm Chris Privitere here at Equinix. I'm one of our integration engineers, and I like to work on Kubernetes and integrate with things like SUSE's K3s. I'll hand off to Dan now. Hi, Dan.
Hi, everyone. This is Dan Callao. I'm a technical product manager here at the solution provider team at Equinix, and I help partners like SUSE integrate their technology with Metal. I'm happy to watch this demo. Eduardo, go for it.
Hello, everyone. Thank you for having me. Yeah, my name is Eduardo Minguez. I work at SUSE. I joined 3 months ago already. And we are happy to be here to present the work that we have been doing to enable deploying K3s on top of the Equinix-Metal. I prepared some slides, so let's go ahead and let's take a look. So yeah, for just a quick introduction on what is K3s, for those that doesn't know what this is. Basically, K3s, it's a Kubernetes distribution, right? So for those that know that what Kubernetes is, basically Kubernetes is just another flavor. So that will be it. Thank you for joining us on this session. Oh, it was a joke, sorry, a bad joke. So what is K3s? As I mentioned, it's basically a distribution of Kubernetes, and it has some interesting features that I would like to highlight. The first of those features is a lightweight Kubernetes distribution. It's shipped as a less than 100 megabytes binary. It contains everything to be able to run Kubernetes, including containerd, kubectl, and all the rest of the Kubernetes components. And it has a small footprint. It only requires a half gigabyte of RAM, and you can even deploy it on a Raspberry Pi or any kind of single board computer. It's worth mentioning that it's even if it's just this small, it's a certified CNCF Kubernetes distribution. You can go click there and you will see the results of the conformance tests. And it's also
Oh, did we lose Eduardo? Yeah. Okay, so Eduardo, it seems as though that we are missing your audio. So here, the slide that you're talking about right now is that the features are that it's lightweight and it has an edge to data center. So you can go from small to an all-in-one. Oh, well, can you hear me? Can everyone else hear me?
Can you hear
me? Okay. Oh yes, we can.
Here we go.
We can hear you now.
Okay. Sorry.
Okay, I'll pass it back to you.
All right. So
Okay.
I don't know when I lost the audio. Did you hear the lightweight and the CNCF thing, or?
Yep, right there.
Oh, all right. Okay. Sorry.
No,
apologies.
You're good.
So as I was saying, you can even deploy it on a Raspberry Pi or ARM64 single board computer, meaning that it fits a lot of use cases, from the edge, where you need a small footprint, a small all-in-one, let's say, deployments, to full-blown HA data center deployment, including etcd. It's also, we call it secure by default, meaning that it's not something, all the communication is TLS, encrypted, and production ready, let's say. And it also has some add-ons, let's say, or batteries included. Those are optionals. They are deployed by default, but they can be removed at installation time or at running time. And those are, you can use traffic as an ingress, Clipper LVs as a service load balancer, and the Helm chart CRD to deploy Helm charts easily. So you probably are wondering why or how are we, making this K3s if it's just a Kubernetes distribution. Basically, we remove all the extraneous content, such as the in-tree cloud providers, storage providers, all the alpha content that is disabled by default, all the deprecated features that are included in Kubernetes, we basically remove them. We remove the non-default admission controllers, and we make this zero dependent on the host. But that doesn't mean that you can deploy all those things on top of it with out of 3 deployments or whatever you want. And also, it's important to notice that by default we use SQLite to store the all the Kubernetes storage, all the Kubernetes objects instead of etcd. And we are working with the Synadia team to enable NATs as a backend storage for the Kubernetes objects. So you're wondering, how do you install K3s? It's really easy. You just need to download the K3s binary and run it, as I put in the slide, like K3s server. Or you can run this curl command that it will download a script where it will basically download the K3s binary. It will create the systemd unit files in order to be able to run it integrated with systemd. You can copy paste this here and there, and you will have the same result. And you can put some environment variables for configuration. All the tweaks and configuration are documented in that particular link if you're interested. So K3s on bare metal. There's some challenges when running K3s on bare metal. Essentially, just like any other Kubernetes distribution, right? Like if we deploy K3s on bare metal, how are going to expose services if there are not cloud load balancers like in regular Kubernetes distribution offered by cloud providers such as EKS or whatever. You can just create a service of load balancer type, and it will be exposed by default to the outside world. But in bare metal is slightly more complicated. We can use node port, but it's not. I'm not going to call it bad practice, but I guess that there's better ways to do such thing. And then how do you expose the Kubernetes API in an HA way, like having 3 control plane hosts? If you don't have any kind of load balancers, you can, of course, bring your own load balancer, either as an appliance or if you deploy your own, HA proxy or whatever. But you need to, if you want to provide HA service, you need to provide, you need to deploy this load balancer in H8 mode as well. So it gets a little bit more complicated. So one solution that we can use for those 2 challenges is that we can use VGP and MetalLB to expose services to the outside world without any kind of load balancer. And I will talk a little bit more about VGP later. And if we want to support HA for the Kubernetes API with no load balancers, we can use a virtual IP that it will be managed via VGP with BIRD. That is, in fact, those 2 solutions were the ones that we choose for this solution for this project to deploy K3s on Equinix-Metal. So BGP, real quick, and those are this is the border gateway protocol. And the summary is that it's a routing protocol used by routers and or hosts to advertise IP addresses. This basically means that you can advertise IPs on different hosts, and the communication between the routers and the host will make the traffic flow from the router or from one host to another based on those advertisements. It can be seen as a load balancing, where typically the balance it's done per connection based on the packet hash. It's typically by the protocol, source IP or destination IP. It can be expanded, adding the source and the destination port. And essentially that this means that there's no need for an external LB. The routers and the host will communicate against each other, and they will choose the best path to reach that particular IP. Apologies if this is not a deep dive on BGP. Probably I did some, I explained it really bad, but you can search or Google for it. So BGP on Equinix-Metal. In order to support BGP communication on Equinix-Metal, you just need to do one thing, basically. You just need to enable BGP at project level. I will show you later how to do that. And then to use the BGP capabilities to serve or to advertise, an IP, you just need to create a public IP. You need to deploy your servers and then install and configure either VERD or FRR. Those are the links to take a look if you want to use BGP on Equinix-Metal. I will show you how we did it or how we solved this in this project. Speaking about MetalLB, MetalLB is a load balancer implementation for bare metal Kubernetes cluster using standard routing protocols. You have the links there if you're interested in know more. There's two ways that MetalLB work. Basically, the first one would be the basic one. Let's call it basic one. It's the L2 mode that uses ARP traffic. So there's no need for a special hardware. Essentially, you just configure MetalLB in a way that it will announce the IP via R, and that's it. And the second one, which is more robust, I guess, it's the VGP, but it requires network gear support, which in this case, as I mentioned before, Equinix does support VGP. In order to deploy MetalLB, you just need to deploy the YAML file that it's already there, or you can use Helm or any other preferred way to deploy this MetalLB component. And then you just need to configure your environment, the IP addresses that you want to use, the BGP peers to connect to if you're using BGP, and so much more. But I didn't want to go into the details. I don't know if there's any questions so far, Walt, then Chris.
Pretty straightforward
All right.
and well explained.
Same.
Okay, thank you.
Straightforward.
All right, so this is what we have been working on. Essentially, we help get in shape, let's say, this Terraform Equinix-Metal K3s repo. And it was a project that it was created a long time ago, but it basically three months ago, it didn't work. There were some changes in the Equinix Terraform provider and on K3s, of course. And then I took a stab at it, and basically I rewrite most part of this project, let's say. So essentially, what we wanted to achieve, it's a way to deploy K3s clusters on top of the Equinix-Metal infrastructure in an easy way. Essentially, we want users to be able to deploy it in minutes, but we want to cover also a wide variety of different scenarios. It's mostly focused on Edge because I'm part of the SUSE Edge engineering team, so that's why we put some more focus on top of that. But it supports, as I mentioned, a lot of different scenarios, starting with single node K3s cluster on a single Equinix-Metal metro. For those that doesn't know what Equinix-Metal metro is, I guess our colleagues from Equinix will probably explain it better, but let's call it an availability zone, right, or a data center. So the first use case will be to deploy just a single node K3s cluster, a small one, just to play with it, to test some stuff or whatever. We go from that scenario to a full HA K3s cluster, including the 3 control plane nodes, using BGP to provide an HA K3s API entry point, as I mentioned before. And then we can mix and match. Like, we can add any number of worker nodes, both for the single node or the HA scenarios. And we can deploy any number of public IPv4s to expose services using the load balancer services via MetalLB, which is deployed automatically. This will probably sound, too much words. Just show me the demo. I will do it later, but I just wanted to highlight all those scenarios and use cases. It supports also the capability to deploy multiple clusters on multiple Equinix-Metal metros, meaning that you can deploy on just a single Terraform apply run. For example, a small cluster in one metro, a bigger cluster with full-blown HA and any number of nodes in the same metro or on a different metro, and any number of clusters essentially. And to demonstrate, one of the Equinix-Metal feature, which is the global IPv4, which is basically you can request an IPv4 that it will be shared among all the Equinix-Metal metros where you deploy a server. Meaning, for example, if you deploy a server on the Frankfurt metro, and then another one on the Dallas metro, and you create on top this global IPv4, it will be routed either to the Frankfurt metro or the other metro, depending on the BGP configuration that you already have. So it will do load balancing on top of the worldwide load balancing, let's say. How to use this? It's really easy. There's that link, the Equinix Labs / Terraform Equinix-Metal K3s on GitHub. You just clone the repo, go to that particular folder, the demo cluster, you run the usual Terraform init, plan, apply, and then you will have a small cluster without, you don't even need to touch the Terraform variables if you don't want, just to try it. It will deploy a small single node cluster on the Frankfurt metro. But of course, you want to, you can tweak it and deploy any number of nodes or any number of clusters, as I mentioned.
I should point out, you will need to get a Metal API key first and put that in there.
Yes. Yeah. There's instructions on the. Let me stop sharing my screen and let me share. Okay, just 1 second, because I want to show you the whole thing. If I go here, so you can see my screen, it should be terminal, and on the left-hand side, it should be the Equinix-Metal UI.
It's a little small, but yeah, we
Yeah.
can see it.
Could you make the text larger or no?
Let me try. Edit session. Text. Is it better now?
Well, that's a little better. Could you do like a Command plus on the web browser as well a little? There we go. Looks good.
All right.
Okay.
Okay, so this is what the Equinix-Metal console looks like. I have this my own sandbox kind of project, and as you can see, there's no servers in here. And in order to use this Terraform module, you need to, first of all, create an API key. I'm not going to do it right now, but you can create your own key here as a read-write, right? And then you need to go back here, and on the project settings, you need to copy this project ID as well. And on the networking side of things, you need to enable BGP. Of course, I have this already enabled, but those should be the only requisites. And in order to deploy the thing, we are going to call Terraform plan, again, with no, Terraform init. Okay, Terraform plan. Oops, I guess the demo bots.
To be in the examples.
Oh yeah, sorry, yeah. Terraform plan. Okay, sorry, yeah. So yeah, as you may see, I just typed Terraform plan. There's no Terraform bars that I use, and it says that it's going to run three resources. The first of all would be the BGP session right here, and then the Equinix-Metal device, which will be the basically the server. So let's apply this right here. And it will take just a couple of minutes. But in the meantime, I would like to show you the repo here, which is basically this one. And there's plenty of information here. All the prerequisites are detailed here, all the variable requirements, what you need to put in place, different scenarios. Like, for example, if you want just a single node in the default metro, you just need to put this on your TF bars. It will produce this output. You can deploy, for example, a single node into different metros, like this one here. And for a much more complex scenario like this one, you just need to define this cluster array, where basically there's 3 different clusters. Those 2 at the bottom are basically single node clusters on this Frankfurt metro. But for this one, we can see that K3s HA is set to true. That will mean that it will deploy 3 control plane nodes on this particular metro. And then we are adding 3 worker nodes on top of this cluster. And then we also reserve 3 different IPs for this particular cluster that will be exposed when you create a service of load balancer kind of type. It will produce this kind of output where you can basically SSH into that particular host. And in this case, we deployed the demo with the global IP. So if we go to this particular URL, when we deploy this thing, it will show you the host or the pod name. And you can see, if you open this link on a different browser or on a different connection, you will see that it gets routed to a different host. If you want to access the clusters, you can copy and paste this snippet to run basically a for loop for kubectl get nodes. And then it has all the details here if you want to go more into the details. So it was timely, it finished, and we have our demo cluster already deployed. If we go to the bare metal servers, we can see that this is just a small K3s demo cluster. On the networking side of things, we can see that for BGP, we didn't deploy anything. So this is just a small demo cluster. And if we SSH into it, because I added already my SSH key to Equinix-Metal, we can see kubectl get pods.
And really quick, by the way, you will also need a Metal account too to get started.
Oh, yeah, of course.
And if you're going to sign up, use this promo code Equinix Live. I threw it there on the bottom left corner or the bottom right corner, depending on how you're watching this. But to get started, you need a Metal account, and you can use that promo code to get started with a discount code from us. So just wanted to call out. You can continue, Eduardo.
Okay, thank you.
Sure.
Yeah, good advice. So yeah, I'm just going to destroy this thing because I don't want to spend any resources, and I will show you how to create a much more elaborated cluster. Like I have these TF bars already populated with the cluster that I would like to deploy. Essentially, this small cluster here with just a single node, this one with the single node plus 1 worker, and this full-blown cluster with 3+ nodes, the IPs and everything else. So Terraform plan bar file bars, and you could see that it will deploy a lot more resources. So let's try this. It will take a little longer probably kind of 5 minutes or so to deploy. So in the meantime, I don't know if there's any questions or if you want to.
Questions for
for
you.
me-
One of the things I usually want to do when I'm deploying clusters like this is customize the node size. Can that be done with this module?
Yes. So if you go to the cluster definition, the Terraform module, let me see if I can find it. You could see
Oh,
here
you're gonna have
that
to
you can.
zoom in there for us.
Oh, sorry. Yeah.
Yeah, that's a lot of just like command plus signs for that one.
There we go. Yeah.
Yeah, I have this, this white screen that it's really, useful for me, but yeah, I get that. It's difficult to read. So yeah, you can specify here different variables for the cluster definition, including the control plane plan or the size. By default, it's the smallest one, but you can choose whatever size you want, essentially, for the control plane and the workers. There's no way as of today to individually set those,
Sure.
right? But per cluster, per either worker or control plane, you can actually do it. You can customize much more things, including the host names. You can put whatever you want here for both the control plane and the node. You can also create your own K3s token. Like how this works is K3s. You can deploy just a single node and then add more nodes into it. You just need to run the same installation script with the API endpoint and a special K3s token that you can either choose to randomly generate it as of today, or you can put whatever you want, like foobar or whatever you basically want. You can also specify the K3s version. By default, it will use the latest one, and the MetalLB version as well.
So one of the questions I had besides that was the IP count setting. If I allocate like 4 IPs, how do I use them, or what are those IPs available to do with?
Good question. So how this works is it will deploy MetalLB right on top of your cluster, and then it will configure automatically the MetalLB to serve those IPs via VGP when you create a service type load balancer.
Oh, okay.
That means, so when you deploy your application, let's call, I don't know, an HTTP server or whatever, and then you want to expose it to the outside world, you just need to create a service, right? Like a regular Kubernetes service, but you put there a load balancer in the type, and then MetalLB will do all the work to be able to expose that IP via VGP to the outside world.
So that's giving me a pool of 4 IPs to work with for the various services
Correct.
that I deployed, which is
Correct.
all right. That's pretty
Yes.
cool. Are they all global, or are they per? Oh, I guess it's in the clusters variable, so it's per cluster, right?
Yeah, it's
Okay.
per cluster. And then as an example, you can put here a global IP equal to true,
Mm-hmm.
and it will create a global IP, right? That it will be served on
Sure.
on all the metros,
So
essentially. And we configure this as the ingress. So by default, if you want to expose an application instead of using a load balancer kind of service, but as an ingress,
Mhm.
it will use that particular global IP.
Oh, awesome. That'll save me some IPs. With the IP counts, can I change that later and have it add additional IPs into the cluster for me?
Yes, that's a good question. But if you, I'm thinking what will happen on Terraform side. Probably it will try to redeploy the whole thing.
Okay.
But you can do it
Maybe
manually
future
if you want.
enhancements.
Yeah, but this is how it works. So the module, so everything that you put here is translated somehow into Terraform things like objects or whatever. But the magic, let's say, happens here. This is the user data. This is essentially how you can hands-free deploy everything, like in cloud environments. This will be used by Cloud Init, where you can put a bash script and it will execute whatever it is. And as I mentioned, the magic happens here using the Terraform template capabilities, like for example this thing here, and playing with some bash tricks. We can be able to install a MetalLB. We can deploy Vert to do the load balancing of the Kubernetes API, and we can do basically whatever. So to your question, if you see here the global, the IP address pool, which is the Kubernetes object that matches the number of, the IPs and all that stuff. For the Anycast, no, but for the IP address pool, it puts here the IP pool. So if you change the number, probably it will need to render this, and it will need to redeploy everything
Gotcha.
to use it. That's a limitation as of right now, but any pull requests features are more than welcome.
That's really cool. So I had a few questions. You talked about this module supporting HA and multi-metro deployments. So what are the key benefits of architecting a multi-metro deployment with this module? I mean, what are our customers getting out of it? Just imagine, a 3 engineering groups, like core engineering, QA, and DevOps engineering, trying to release an application into one metro, which is going to be a production facing, a public facing production metro. Can you tell us like how would this multi-metro deployment would benefit a customer in this scenario?
Sure. Yeah. So going back to this example that I just deployed, I call the 3 different clusters that I deployed as with different names. So, for example, in your to your question, Dan, you can deploy a small development cluster for engineers, right, or for test or pre-production environments, like those 2 ones. And then you can deploy your full blown HA cluster at the same time, let's say. So you can mix and match different use cases. Of course, you can run it multiple times if you want. You just want to deploy a single cluster in a run and then another single cluster on another run with different Terraform variables. You can do basically wherever it's needed. But using this approach of running this on this single run enables you the global IP thing that I just talked about. Let me show you real quick this thing here. So if you go to that particular URL, you could see that I'm routed to this Frankfurt Dev cluster, right? But if you go to your browser and put this URL here, you will probably be redirected to another cluster, which is one of the benefits of using this as the Anycast IP or the global IP goes routed to different metros or different cluster on different metros. Sorry. I don't know if that answered your question.
The other question, yeah, I think that's well explained. I think the other question I had is like, as far as managing all these clusters that are deployed in multiple metros, how can one easily manage these clusters? Is there like an API endpoint, or what kind of tools
Yes.
Can they support?
In fact, this output here is the Kubernetes API of each of those. So if you go back here, let me show you this because you already merged it. So if you go here to the accessing the cluster, right? You paste this here. You could see that I have kubectl access to all of them, right? Like I have this first cluster that it only contains this single node, this one here that has a control plane and a worker node, and this big one here that has everything on top. And if we want to get the kubectl, the kubeconfig files, we can run this. And then after a few seconds, show you, you can see that I have already here the kubeconfigs. So I can put this here, kubeconfig, SB production. And with this kubeconfig file, basically I have access to the Kubernetes cluster. What you can do after this, you can deploy Rancher on one of those clusters and then connect all the other clusters, and then you can manage them in a friendlier web UI way if you want. In fact, this is one of the next steps for me for this module, to be able to deploy Rancher Manager easily, so you can manage all those clusters from this single pane of glass, I guess.
Very cool. The other question I
do
had
you-
is,
oh, go
what's the default OS that's deployed within the control and data planes?
Yeah, that's an interesting question as well. I put that on the next steps for you as well. But yes, by default, it's using Debian 11, mainly because there's no support for SUSE's SLI Micro yet on Equinix-Metal. I know that we are working on having this ready as soon as possible, because we at SUSE, of course, we want to deploy K3s on top of our best operating system, which is SLI Micro, which is the immutable edge-focused SUSE distribution based on SLES, of course. So yeah, by default right now it's using Debian 11, but we are working with our Equinix-Metal colleagues to be able to deploy SLI Micro on top of Equinix-Metal, and then do the changes that are required to run this this module on top of that operating system. I can go back to the slides for the rest of the presentation, including the next steps, if you want.
Me.
Okay, let me.
Chris, did you have a question?
No, I got answered.
Okay, so yeah, essentially, as I was mentioning before, let me share my screen real quick. This one.
How's that look? There you go.
So for the improvements, as we were been just talking, we want to make SLI Micro the default operating system. We're working with the Equinix engineering team to support SLI Micro on top of the Equinix infrastructure. We want also to be able to choose either K3s or RKE2. RKE2 is just another Kubernetes distribution by SUSE that it's more focused to, it's not as small as K3s, but it has some other interesting features, such as the different CNI providers. It's government, US government certified distribution as well. So it depends on the use case. You will either deploy K3s or RKE2. And as I was mentioning, deploy Rancher on top of the cluster and connect them all to this Rancher cluster. And that's it for me. Any more questions? Any last comments?
What's easiest way to get started here?
Just go back to the Terraform, this repo here, the Equinix Labs Terraform Equinix-Metal K3s. Take a look at the README. Of course, create your own Equinix-Metal account with the code that Walt previously shared with you, and then just run, those commands. You will be able to get a K3s cluster in a couple of minutes.
And everyone listening should really go try it. I did this last night. It was so fast and just really slick how quickly it came up and how everything was load balanced across the world just out of the box. I love it.
Yeah, thank you.
Yeah, so I'll throw the link here. So it's a little bit larger. It's a link that you see there above, but it's just there's the GitHub link. And also, I'll do a call out for how to get started at Equinix. You would just go to our Get Started page. So let's see if I can fire that up somehow. Let's see if I have that somewhere here. Wait, I just had it. Well, you can just go to our Metal page. Give me a like few seconds, then I'll just throw the link up on the page there. And then once you're on that page, then you can use this promo code, which is lowercase Equinix Live. It's usually there at my captions, but it wasn't there today. And then I guess that's it. So here, let me just throw it up here. I'll say here, get started. And there's a link here below. So get started. And so you can just go to deploy.equinix.com/get-started. I just want to make sure that I had the URL correct. So, all right. And so that's how to get started with Equinix and then K3s on Metal. Any last words? Anyone? Nothing? Okay.
Nothing from my side. I just want to, thank you all for having me. It's been a blast. And yeah, any kind of improvements or issues that you find, feel free to open a GitHub issue or a pull request, and I will be happy to take a look.
Cool. And will these slides be available at all, Eduardo?
I can send you the PDF, and you can put it somewhere.
Okay. All right. Or if you're just watching the video, then I guess that you can just, go forwards and backwards and, just follow along. So, all right. So that's it. Don't forget to follow the channel and to subscribe. Yeah. So thanks to all three of you. And I guess that we'll just sign out.
Thanks,
right.
Walt.
All right.
Thank you. Thank you, guys.